Welcome to EPG Pathshala. Our today's module is handovers in GSM. In the previous modules, we had discussed the architecture, localization and calling in GSM. It is, we had discussed the basic architecture of the GSM in the three subsystem, that is the radio subsystem, network subsystem and the operation subsystem. We had seen that how mobile device is localized or found in the GSM network. So, what type of identifiers are used to localize the mobile device in the GSM network, and how a call is being made from the landline phone to the mobile phone in the GSM network and from the mobile phone to the landline phone. In today's module, we will be discussing that how handovers are handled in GSM. So, in today's module, we will be discussing what is a handover, why the handovers are required, what are the different types of handovers, which handover is used in GSM, what is the criteria for handover, and by an example, we will see that what all mechanisms take place when a handover is being done. So, to start with, what is a handover? Handover is a situation very typical to the cellular systems. Why? Because we had seen when we discussed cellular system in the previous modules, or that in a cellular system there is a base station or an antenna at the center of the cell and it radiates with some power. So, the signals received from that base station or the antenna are limited only to a certain distance depending on the power of the antenna. We had also seen that if the cells are in the suburb areas of the cities, they are large in size, that is the power of the transmitter is large, it can reach to a longer distance, whereas when the cells are in densely populated cities, the cell sizes are small, the power of the antenna is less. So, we had also seen that when the cell sizes are small and the mobile device moves from one cell to another cell, that means when it will reach the boundary of the cell, the signal received from the base station or the antenna of that particular cell will reduce as per the distance from the base station. We had seen that the signal strength decreases inversely as the square of distance from the base station or the antenna. At the same time, when it is going away from a particular base station, it is also getting closer to another base station in the nearby cells. So, as it is receiving low signal strength from the current base station, it might be possible that it is also receiving a strong signal from the nearby base station. So, to provide the seamless connectivity of the voice or the data transfer, the call or the data transfer of that particular device should now be handed over to that new base station, so that the connectivity is not lost. This process is known as handover. Handover is a mechanism when the call or a data service is transferred from one cell to another cell, or in particular from one channel to another channel. We will see that what are the situations in which handovers are required. The first situation we just discussed, that is when the mobile device moves out of range of one cell or base station and gets much stronger signals from another base station. The second is that if the entities above the cell, that is the BSC and the MSC, which we discussed in while discussing the architecture of the GSM network, finds that the traffic in a cell is very high, that is the channels or the frequencies allocated to that particular cell are now getting exhausted. So, some of the mobile stations which are using those particular frequencies are moved to the nearby cells which have got less load, if possible at all. So, if it is possible to move that particular mobile station to the nearby base station where the load is less, then this situation is also known as handover. Why? Because now the channel which has been allocated to the mobile station from that heavily loaded cell is released, and the new channel from the new base station or the new cell is been allocated to the mobile station. So, there is a redirection of the channel from one cell to another cell to the mobile station, and hence this is also a situation of handovers. This phenomena is known as load balancing. Now, what should be the condition for an efficient handover? An efficient handover mechanism should not perform a cutoff in the service, also known as call drop in the case of calls. So, basically there are two types of handovers, hard handovers and soft handovers. What are hard handovers? Existing radio link from the current base station must be dropped for some period of time before connecting to new base station. Like a mobile station is making a call using a particular channel from a current base station. So, when it starts receiving low signal from that particular base station and it receives strong signals from the new base stations, then channel or the link which has been used should be which it is currently using and is of low quality should be disconnected for some particular period of time. Now, during this period of time, no voice or data takes place. A call is redirected from the old base station to the new base station or from the old frequency channel to the new frequency channel. Now, this break is very short. Now, you might wonder that if there is a break, why don't we observe it? There must be a call drop, there must be a cut off, which the time or the duration for this interruption takes place is very less, which is hardly observable by the user who is talking, and of course not observable during the data transfer, because GSM maintains the interruption period of just 60 millisecond. So, you can see that a 60 millisecond is a time which is hardly being observed, a time of interruption which is hardly being observed. You just take a breath while you are talking and the channel will be taken away and the new channel will be allocated. You won't even realize. The another category of handover is soft handovers, in which the mobile device gets hold of both the channels in the neighboring cells at the same times, and hence the transition or the handovers are seamless or smooth. That is, there is no need to break the connection with the old base station and then reconnect to the new base station. The mobile station is in link with both the base stations at the same time. This type of handovers is very common in CDMA, because in CDMA the whole of the bandwidth is available to all the users at all the time. So, there is no use of releasing the old frequency channel and get the new frequency channel. GSM uses hard handovers, whereas CDMA uses soft handovers. Now, depending on how the mobile device is moving, from which area to which area it is going, the handovers are divided into 4 categories: intra-cell handovers, inter-cell, that is intra-BSC handovers, inter-BSC, intra MSC handovers, and inter MSC handovers. Now, what are these terms? These terms we had already discussed in the previous modules when we discussed the architecture of the GSM. We have seen that there is a hierarchical structure in the architecture of GSM, that is, you have a mobile station. The mobile station is in range with a particular BTS, which is also known as base transceiver system. More than one base stations or the BTSs are controlled by a BSC, and more than one BSCs are controlled by the MSCs. So, one particular BSC can have the hold of many base stations, one MSC has the control of many BSCs. So, this is the hierarchy which is maintained. So, the 4 categories of handovers which we just discussed depends on that how the mobile device is moving. So, when we say that it is a inter-cell intra-BSC handover, it means that the mobile device has moved from one cell to another cell which is in the same BSC area. So, this type of handover will be controlled by the BSC. When we say that it is a inter-BSC intra MSC handover, it means that the mobile device has moved from one BSC area, from a cell to another cell which is in the different BSC, but in the same MSC area. That is, the 2 cells belong to different BSC areas, but in the same MSC area. When we say that the handover is inter MSC, it means that the 2 cells from which the mobile station is moving belongs to the different MSC areas. And when we say that it is intra-cell handover, that means the device is within that particular cell only, but still it needs a handover. So, when would I require a intra-cell handover? That is the frequency channel which the mobile device is using. There is lot of interference on that particular frequency channel, or the signal quality is very poor using that particular frequency channel. So, in that case, that frequency channel will be taken and a new frequency channel will be allocated to the mobile station. So, the mobile station is within the same cell, yet the voice or the data transfer is redirected from one frequency channel to another frequency channel. In this case also it will be known as a handover. So, handovers does not necessarily mean that the mobile device is moving from one cell to another cell. That is, a mobile device is in the same cell, yet the transmission is redirected from one frequency channel to another frequency channel, or from one time slot to another time slot, or from one code channel to another code channel. So, this type of handovers are known as intra-cell handovers. Intra-cell handovers can also be triggered if there is more load on one particular frequency channel. So, the transmission of the mobile station will now be redirected to a frequency channel which is less loaded. In that case also it will be a intra-cell handover. Just look in the diagram shown in the PPT. You can see that there are 4 cells C1, C2, C3 and C4. All the cells belonging to 4 BTSs, that is base station transceiver systems. BTS 1 and BTS 2 are controlled by one BSC, that is base station controller. BTS 2 is controlled by BSC 2, BTS 3 is controlled by BSC 3. Now, you can see that BSC 1 and BSC 2 are controlled by MSC 1, BSC 3 is controlled by MSC 2. Now, let us see that which type of situations it will be intercell, intracell, inter-BSC or inter-MSC. So, you can see that in the first case the handover is within the cell only. So, it is a intracell. In the second scenario, you can see that the mobile device has moved from one cell to another cell, but in the same BSC area, that is from C1 to C2, both belonging to BSC 1. So, in this case the handover is called intercell and intra-BSC. In the third scenario, you can see that the mobile device is moving from C2 to C3. So, in this case the two BSCs are different, but both the two BSCs are belonging to the same MSC, that is MSC 1. So, the handover is from BSC 1 to BSC 2. So, this scenario is known as inter-BSC intra-MSC handover. And in the fourth scenario, when the mobile device moves from C3 to C4, both belonging to different MSC areas. So, handovers which will take place in such a situation is known as inter-MSC handovers. So, you can see in the figure that the 4 scenarios of handovers which we discussed has been clearly depicted. Intracell depicted by scenario number 1, intercell intra-BSC designated by scenario 2, inter-BSC intra-MSC designated by scenario 3 and inter-MSC designated by scenario 4. So, these are the different types of handovers which can take place. Now, we will see that what is the criteria for the handover. So, when it is decided that there is a requirement for a particular handover. So, we will just see that how the measurements are being done on the quality and who takes the decision that the handovers is to be performed. So, the next topic is the handover decision. We have seen that handovers are caused due to low link quality. Now, what do you mean by low link quality and what are the measures of this quality? The measures of this quality is the signal level and the bit error rate. Now, who performs these quality measurements? The answer is both the base station and the mobile phone. The base stations and the mobile phone are periodically performing measurements of the quality of both uplink and downlink, of the current base station or the current link as well as for the neighboring links or the links in the neighboring cells. Now, why they want to do these measurements on both the links, that is on the current link also as well as on the neighboring link also? Answer is simple. From wherever they get the better quality, the call or the data transfer should be handed over to that particular link. So, what the mobile station and the base station do? They periodically perform the measurements of the quality in the form of the error rate and the signal strength and produces reports. A mobile station forwards this report to the base station. The base station itself performs the measurements and forwards these reports to the BSC and so on. Now, till now we have the measurement reports. Now, what is done with this measurement reports to take the handover decision? As I said that the reports are for both the current link as well as for the neighboring link. So, if the neighboring link is having a better quality, the call should be forwarded to it, and if the current link is having a better quality, no need of handover, so the call should be resumed on this particular link only. So, there must be some, if there is a significant difference between the two link qualities, then and only then a handoff will be initiated. But what about this significant? How do I quantify this significant difference? So, this difference between the two link qualities is known as Cho margin, handover margin. Now, if there is a difference greater than this threshold, handover should take place, and if it is less than this threshold, it means that both the channels or both the links are of more or less equal quality, and hence no handovers should take place. But ultimate care should be taken while setting this Cho margin. Why? Because if the Cho margin is very large, that is, I am waiting that the difference should go up to a considerable amount and then and only then I will perform the handover. In that case, a call drop can take place. But what if the Cho margin is very small? If the Cho margin is very small, then the frequent handovers will take place. So, even if there is a small signal quality degradation due to a shadowing effect or due to interference, then also it will measure the quality, it will say that the quality is degraded and it will instigate a handoffs. This is known as a ping pong effect. So, care should be taken to set this Cho margin. So, what are the two thumb rules? First, it should not be very large, because in that case it will cause more of call drops and cutoffs. It should also not be very less, because in that case frequent handovers would be instigated. Once it is found that the difference between the two signal qualities is greater than the Cho margin, then the decision for the handovers is taken place. What happens during this handover mechanism, we will just see by taking an example of inter-BSC, Intra MSC handovers. So, you can see in the figure that there is a mobile station which is currently residing in the old base station area. This base station area belongs to a particular BSC, and now there is a new base station area from which the mobile device is getting the signal. That new base station is belonging to the new BSC areas, but belonging to a same MSC. You can see in the diagram that there is a mobile station, then BTS old indicates the old base station of the mobile phone, BSC old indicates the old BSC area, both belonging to the same MSC. BSC new indicates the new BSC area, and BTS new indicates the new base station area. Now, what all things take place when the mobile station moves from this old BSC area and a handover is required. As we said that measurement reports are generated by the mobile station and the base station. So, the mobile station and the base stations perform the quality measurements for the current and the neighboring links. Measurement reports are prepared. The mobile station forwards this measurement report to the old base station. The old base station has itself generated a report, so it forwards its own report along with the measurement report received from the mobile station to the old BSC. Now, BSC decides whether the HO decision has to be taken or not. So, once it finds that the HO is required, it gives the HO required message to the MSC, because we had already said that when there is a handover from one BSC to another BSC belonging to the same MSC, the MSC takes control of these handovers. Now, this HO required message is forwarded by the MSC to the new BSC area. MSC sends the HO request to the new BSC and also request the resources required for the handovers. It is important because if the mobile station is getting the strong signals from the new cell or the new BSC areas, and if there are no available resources there, that is, what are the resources? Resources in the form of a frequency channel or in the form of a time slots or in the form of a code channel, then there is no point performing the handovers there because there no resources are available. So, again there will be a call drop situation similar in which the mobile station currently is. So, MSC sends HO request to the new BSC area and a new BSC and requests the resources required for the handovers. If the resources are available, then the BSC activates new channels at the new BTS and sets the stage for the arrival of the mobile station. The new base station acknowledges the channel activation BSC. You can see in the diagram that the channel activation acknowledgement message is sent from the new base station to the new BSC. Now, the handover should take place. The handover is initiated by sending a HO command by the MSC to the old BSC. This you can see in the diagram that this message is forwarded to the old base station and then finally to the mobile station. So, the HO command tells the mobile station to break the old radio link and access new link provided by the new base station. So, when the mobile station receives the HO command, now it understands that the connection with the old radio links should be broken up and the new link provided by the new base station should be accessed. So, you can see that the link establishment takes place in the next step. The link is established by link establishment message followed by the HO complete message. So, the HO complete message is sent from the new base station to the new BSC, and then finally the clear command is sent to release the resources at the old BSC and the old base station, and the clear complete message finally signals successful handover. So, we have seen the complete activity diagram of the handovers from one BSC to another BSC belonging to same MSC, that is, the handover is inter BSC, intra MSC. In this module, we have seen that what are handovers, why handovers are required. So, we have seen that handovers is a situation very typical in the cellular systems only, because in the cellular systems the signal of the signals from a particular base station degrades significantly, and hence the handovers are required to the new base station. We have seen that there are two type of handovers, hard handovers and soft handovers. Hard handovers are used in GSM, whereas soft handovers are used in CDMA. We have also seen that how the handover decision is being taken, that is, who takes the handover decisions. Handover decision depends on the handover margin, which is the difference between the two significant signal qualities received from the neighboring cells. Then we have seen the basic mechanism of a handovers between one BSC to another BSC belonging to the same MSC area. So, we have discussed how handovers take place in GSM telecommunication standards. In the next module, we will be discussing the security mechanisms in GSM. Till then, have a nice day.